Lecture 16, Production and Economic Growth. To start off this section, I'm going to go through a series of countries that experienced growth miracles over the last 20 years. We'll start off with Shanghai. So in the picture above, what you'll see is a 1990s Shanghai, and this is exactly the same photo taken from the exact same spot of Shanghai in 2010. Notice the type of transition and economic growth that occurred during those two time periods. Next, we'll head to Singapore. This is Singapore 2000 in year 2000, so 20 years ago, and this is Singapore today. This entire section here was created out of land that came from Indonesia and Malaysia. So they brought the sand here, and then they eventually built all of this. And currently they're working on building everything behind this as well. Here's Dubai. This is Dubai in 2005. And again, this is a photo of exactly the same location, but taken, I believe, a couple years ago. Must have been 2-3 years ago, because here we have the current tallest building in the world. So these countries experienced growth miracles. And those miracles weren't just due to chance, they were due to very specific planning in order to achieve those goals in such short periods of time. So this lecture asks a few questions. First, what are the facts about living standards and growth rates around the world? Let's see, is the world the same or is it different? Second, we'll look at what determines productivity and its growth rate. Then we'll look at why productivity matters for living standards. And finally, how can public policy affect growth and living standards? This is showing us the GDP or real GDP in a series of different countries from the period of 1900 to 2014. And those dollars are adjusted to 2014 dollars. And the growth rate here is basically an average rate of growth across the whole time period. So you can see in Brazil, they started with a GDP per person of $828 in 1900, and in 2014 they were up to $15,590. This was a growth rate of about 2.61% per year. Let's contrast that to the United Kingdom, where we have data back from 1870. And in 1870, the United Kingdom had a GDP of per person of 5,117. And at the end of the period, about 40,000 per person. They experienced a growth rate of 1.42% a year. And you could see that the United States is very similar to the UK as well, and experienced 1.8% growth per year during that time period. So there's vast differences in living standards around the world, and you can see there's also fairly good variation in the growth rates around the world. Let's look at income around the world. So here's GDP per capita in 2012, and this is the GDP growth rate from 1970 to 2012. So this is only a short period of time there. So this is, we're looking here at China, Singapore, India. A lot of these are the emerging giant countries like China, Singapore, India, Japan. It was not really anymore. Others, Philippines, and so on. So you can see that China and Singapore have growth rates of over 4%, and China remarkable 7.5%. And you can see the United States during that same time period of about 1.8%, fairly low growth. And we can look at countries like Chad that basically didn't even grow 1% per year during the period of 1970 to 2012. So again, there's differences in living standards around the world. There's differences in growth rates around the world as well. Notice that the GDP per capita in Singapore is in fact higher than the GDP per capita in the United States. And on this chart, it has the highest GDP per capita in the world. So since growth rates vary, the country rankings can change over time. So poor countries are not necessarily doomed to poverty forever. Singapore incomes were low in 1960 and very high now. So if we compare, in 1960, US GDP per capita was $13,415, and in Singapore it was $428 per person. Today, the US GDP per person is 62,794, and in Singapore, it's 64,581. So we could see that Singapore had a giant leap forward during that time period. One little key insight is rich countries can't take this for granted. They may be overtaken by poorer and fast-growing countries. We'll look to see the relationship of how poorer, fast-growing countries can catch up and converge to the rich countries. Now, this is a little key takeaway here, that in certain cases, former rich countries can become growth disasters. Right? We'll look at the case of Argentina in a special assignment you guys will do in Brightspace. The Rule of 72, or sometimes also called the Rule of 70, states that in order to estimate the number of years a variable to double, take the number 72 and divide it by the growth rate of that variable. So for example, if the growth rate in China is 10%, and the Rule of 72 predicts it would take 7.2 years for China's real GDP to double. Current US GDP growth is at about 1.8%. How many years will it take for US GDP to double? So we take the 72, divide it by 1.8, and it would take us approximately 40 years to double our GDP. If, however, our GDP growth was to tick up to, say, 3% per year, just a small little increase, our GDP would double in 24 years. So just a small increase would actually make our GDP double in a very quick period of time. Now later on we'll answer the question as to how likely it is and how easy it would be for us to get to a GDP growth rate of 3%, and the answer is it's not that simple. So income growth around the world. Why are some countries richer than others? That's the key question. This was the question asked by Adam Smith when he wrote The Wealth of Nations. And the answer is there's many, many different reasons. Why do some countries grow quickly while others seem to be stuck in a poverty trap? And what policies may help raise growth rates and long-run living standards? Let's start by looking at the production function. So we've discussed the production function before. Recall from previous lecture when we talked about the costs of production, we created this formula where we had output, or Y, is a function of labor, capital, human capital, and natural resources. And we can think of that human capital a little bit like our entrepreneurial ability that we saw before. This A is actually technology. It augments our production function. So here we see we take physical capital, human capital, and technology. We generate our aggregate production function, and then that generates our GDP. Productivity basically helps us understand the quality of our standard of living. A nation's ability to produce goods is what allows it to have more income. So if we take our production function and we want to convert it into per worker terms to basically assess how productive is each unit of labor input, we take our real GDP Y and we take the amount of labor units we have and we divide Y over L and we get our output per worker, and that's what we will think about as worker productivity. So productivity is when a nation's workers are very productive, real GDP is large, and incomes are higher. When productivity grows rapidly, so do living standards. What then determines productivity and its growth rate? Now, I want you guys to think about economic growth as basically looking at this production function. Here we have two goods/services, education and healthcare. Right, and here we're seeing a shift of the production possibility frontier of the PPF, where we're able to enjoy more of both goods. This effectively is the increase in economic growth, usually due to some kind of change in productivity. This is the output per worker. This is a graph of output per worker productivity in the US from 1960 until 2005. So an economy's rate of productivity growth is closely linked to the growth rates of its GDP per capita, although the two are not identical. A common measure of US worker productivity is the dollar value per hour the worker contributes to the employer's output. This measure excludes government workers because their output is not sold in the market, so their productivity is hard to measure. So this graph shows the average amount produced by a U.S. worker in an hour averaged over $100 in 2011, more than twice the amount an average worker produced in 1966. So here's 1966, about what, $30 per hour? And then in 2005, we're close to $100 per hour. Let's practice measuring productivity. So let's assume that a country's GDP is 150 billion. It has 1 million workers that work 2,000 hours a year. To find the productivity, we take the GDP and divide it by the number of workers and the number of hours each work per year. The value of output per worker would be $75 per hour worked. So the higher your productivity, right, or the output per hour per worker worked, the more productive your economy is, and therefore you tend to have a higher standard of living. This is a little illustration about what productivity looks like. So this is an example. Fewer cows, but more milk. This diagram here on the left shows us the number of cows and the number of cows in millions between 1920 through 2000. And you can see that initially they went up to about the 1944-45, and then it started to drop off from then. But at the same time, during that same period, we saw there was a fairly strong positive growth in the productivity or milk production of cows in billions of pounds. So Wisconsin farmers produced 2.5 times as much milk as they did in 1924. This is what we can show as productivity in the real world. What else defines productivity? Well, let's look at physical capital per worker. This is the amount of capital each worker has to work with. So in order to get physical capital per worker, we do the total amount of capital and we divide it by the number of workers, and we get the total physical capital per worker. So productivity is higher when the average worker has more capital, machines, equipment, etc. So an increase in capital to worker causes an increase in output per worker. We'll look at this graphically in a later slide. We also have human capital per worker. Human capital is the knowledge and skills workers acquire through education, training, and experience. To get the average worker's human capital, we take total human capital divided by the number of workers in our economy, and we get the average human capital per worker. Productivity tends to be higher when the average worker has more human capital, so that's education, skills, etc. So an increase in the amount of human capital per worker tends to increase the output per worker, or the productivity. Natural resources. Natural resources are another of the inputs into our production process that come from nature. Other things equal, more natural resources allows a country to produce more goods. So as the natural resources per worker goes up, it causes an increase in the output per worker. Some countries are rich because they have abundant natural resources, such as Saudi Arabia, but countries need not to have lots of natural resources to be rich. Japan imports most of its natural resources. So there's more important things than natural resources in defining which countries are rich and which are poor. We will have a look at this later when we can see that natural resources in certain cases could actually be a curse. Technological knowledge is society's understanding of the best way to produce goods and services. This does not only mean faster computer, higher definition TV, or smaller cell phone. It means any advance in knowledge that boosts productivity and allows society to get the most out of its natural resources. Think of Henry Ford and the assembly line, right? It was just a rearrangement of the way the work is being done. It wasn't a new technology, it was just a rearrangement of information or knowledge. Let's compare technological knowledge versus human capital. Technological knowledge refers to society's understanding of how to produce goods and services. Human capital results from effort that people expend to acquire knowledge. Technological knowledge can be easily shared among many producers. Human capital is tied to the individual who expends the effort to acquire it, like going to school and learning how to do a certain discipline. If someone discovers the most cost-effective way of manufacturing cars, this knowledge can be shared with all auto manufacturers, causing a general increase in productivity in the auto sector. If someone acquires some skills or experience that enable him or her to do his or job better, then his productivity rises, but not of all persons in the occupation. Let's look at the production function and diminishing returns. We've already seen a little bit of this in an earlier chapter when we talked about the diminishing marginal product of labor, diminishing marginal product of capital, and this is a similar idea. So here on the y-axis we have output per worker, and on the x-axis we're just going to have capital per worker. This is the production function, okay? So this is y is a function of capital and labor, etc. So if workers have a little bit of capital, okay, so if we start at this country, say this amount of capital per worker, and it has one amount of output per worker. If we give them a little bit of capital, what we notice is that little bit of capital from 1 to 2 creates an increase in output that is actually greater than the change in capital. So if however, we start with a country where you have a lot of capital per worker, such as the United States, when you give them, say, the same amount of capital as the previous country, what you tend to see is that the increase in the output per worker is actually very, very small. So as a country acquires more and more capital per worker, you notice that the production function tends to get flatter and flatter. And therefore, additional units of capital don't necessarily cause output or GDP to grow in an effective way. What typically has to happen in this type of country to experience economic growth is that you actually have to have a shifting of the production function, just like this. And this would typically happen due to changes in technology. You'd get a shifting of that line. Okay, so in the United States, really trying to spend more time in encouraging investment in capital isn't going to necessarily yield an extensive amount of increase in our GDP growth. However, investing in technology, that would be a different issue, and we could potentially boost our GDP growth as a result. The catch-up effect. This is the property whereby poor countries tend to grow more rapidly than rich ones. So a poor country starts here. A rich country will start at a point like this here, right? In terms of output per worker, we'll call this R, and we'll call this P. Now, if you give the poor country a little bit of capital, you notice that their output per worker tends to increase quite substantially. If you give the rich country the same amount of capital, their output tends to grow a lot less, right? It tends to be very small. So this effectively is actually a case for foreign direct investment that basically says that poor countries, if provided with capital equipment or capital inventory, will tend to grow faster than rich countries. So the catch-up effect, over 1960 to 1990, the US and South Korea devoted a similar share of GDP to investment, so we might expect them to have similar growth experiences. But growth was greater than 6% in Korea or South Korea and only 2% in the US. The explanation is the catch-up effect. In 1960, the capital to labor ratio was far smaller in Korea than it was in the US, hence it had Korea grow faster. Foreign investment. To raise capital to labor ratios, the government can encourage foreign direct investment and foreign portfolio investment. Remember that increasing the capital to labor ratio will increase productivity, wages, and living standards. Foreign direct investment is when a foreigner comes into the United States, opens a factory, and starts producing goods out of the United States, right? And this would be true of, let's say, an American firm going to China and producing goods, then would be a foreign direct investor there. Foreign portfolio investment is the investment in financial assets. So for example, if, let's say, someone from Japan bought US stocks, that would be a foreign portfolio investment. Some of the returns from these investments flow back to the foreign countries that supplied the funds. This is especially beneficial in poor countries that cannot generate enough savings to fund investment themselves. Also, this helps poor countries learn state-of-the-art technologies developed in other countries. Education. Government can increase productivity by promoting education or investment in human capital. Right? This includes investment in public schools, subsidization loans for college, etc. Education has significant effects. In the US, each year of schooling raises a worker's wage by 10%. But investing in human capital also involves a trade-off between present and future investment. Spending a year in school requires sacrificing a year in wages to have higher wages later in the future. Let's look at South Korea as an example. In South Korea, universal enrollment in primary school had already been achieved by 1965, when Korea's GDP was still near their rock bottom low. By the late 80s, Korea had achieved almost universal secondary school education. With regard to physical capital, Korea's rate of investment had been about 15% of GDP at the start of the 1960s, but doubled to 30 to 35% by late 1960s and early 1970s. With regard to technology, South Korea students went to universities and colleges around the world to get scientific and technical training, and South Korean firms reached out to study and form partnerships with firms that could offer them technological insight. These factors combined to foster South Korea's high rate of economic growth. Over the next few slides, we're going to be looking at in detail about the contrast of North Korea and South Korea and how institutions have led the way to making South Korea a growth miracle and North Korea a complete growth disaster. What are institutions? The price system allocates resources to their most efficient uses. This requires the existence of property rights, which is the ability of people to exercise authority over the resources they own. In many poor countries, the justice system doesn't work very well. Contracts aren't enforced, fraud and corruption go unpunished, and in some firms must bribe government officials in order to get permits. Political instability is another issue, and it creates uncertainty over whether property rights will be protected in the future. When you have these kind of things combined, contracts not being enforced, property rights not being protected, you tend to see a situation where institutions are failing and therefore economies tend to also go in that same way. Let's look at the contrast of North and South Korea. We've seen this image before, which is the night picture of the Korean peninsula. Again, looking at lights is actually a fairly precise way of assessing economic wealth, because the more lights in a city, that typically tends to mean the wealthier the city is. As you can see in North Korea, you have very, very few lights. Let's compare and contrast North Korea's growth path in terms of GDP. If you notice, in the 1950s, if you compare, you see they were going at about the same rate till about 1960. And then you saw South Korea explode, whereas North Korea really hasn't changed at all since 1950 in terms of their GDP per capita. Well, why is that? Well, remember, after the Korean War, North Korea adopted a communist society and authoritarian regime, oppressive, extractive authoritarian regime with a strategic eye purely on military ventures. South Korea, however, adopted what is called outward-led growth and embraced capitalism and was able to grow its economy substantially. Let's look a little bit in more detail. Let's look at a few simple measures. Let's look at average height. In Korea, South Korea, the average height is 173.5 centimeters. In North Korea, however, as a result of the shift, we see that they tend to be 3 to 8 centimeters shorter than South Koreans on average. Right? If we look to compare the population, right, the population in North Korea is about half of South Korea. If we look at life expectancy in North Korea, it's about 69 years, in South Korea, 79. If we look at things like press freedom, the freedom of the press, South Korea is 50th in the world and North Korea is 178th, and that's out of about 180 countries. If we're looking at GDP per capita, in North Korea, it's about 1,800. In South Korea, in 2012, it was 32,000. Now it's around the 45,000 level. Infant mortality, 26%, 26 out of 1,000 births die in North Korea, and only 4 out of 1,000 in South Korea. And you can see how this works. One place where North Korea does substantially surpass South Korea is military expenditure and active duty. You'll notice that North Korea spends 22% of their GDP on military expenditure versus South Korea that spends only 2.8%. Here you can see how contrasting institutions lead to this very, very contrast in terms of, we can say, life quality, we can say standard of living, etc., between two countries that effectively were the same until about 50 years ago. Trade policy. So countries can adopt what are inward-oriented policies, which include tariffs, limits on investment from abroad, as a means of raising living standards in their own country by avoiding interaction with other countries. Not a really good policy. Outward-oriented policies look to eliminate restrictions on trade or foreign investment, and they promote integration with the world economy. Trade has similar effects to discovering new technologies. It improves productivity and living standards. And remember that it allows countries to consume outside their production possibilities frontier. So countries with inward-oriented policies have tended to fail and create growth. And an example of that is Argentina during the 20th century. Argentina in the 1950s was an economy booming, right, with a very high standard of living, and since then has gone through one financial crisis to another and has become a growth disaster. Countries with outward-oriented policies have often succeeded. We can look at examples of South Korea, Singapore, Taiwan, all after the 1960s. Research and development. Technological progress is the main reason why living standards over a long run rise. One reason is that knowledge is a public good, so ideas can be shared freely, increasing the productivity of many. Here this chart looks at a comparison of 5 countries and their investment in research and development since 1996 to today. If you'll notice, one country stands out, and that's South Korea, right? Even the US here, the blue line tends to be fairly stable, and so does Germany, Japan as well. China seems to be raising, but you can see that South Korea has the highest R&D as terms of percentage of GDP, which effectively could have led to their dynamic growth. These policies tend to promote technical progress, patent laws, tax incentives or direct support for the private sector research and development, and grants for basic research at universities. So if we want to promote technical progress, these are the policies. You guys will be watching a video that is going to help you guys think about the patent laws and how important they were to the creation of the United States economy. Population growth may affect living standards in 3 different ways. First, it may stretch our natural resources. Thomas Malthus had a theory that population growth would strain society's ability to provide for itself. He assumed we had a fixed amount of resources, which is in fact correct, and he also assumed that we had an unlimited amount of wants. And basically, as humanity kept reproducing and population kept growing, he believed that we would have basically effectively wiped ourselves out by this point. But since then, world population has increased about 6-fold. If he was right, our living standards would have fallen, but in fact, they've risen so substantially, particularly in Western economies. The second way that population growth could impact productivity is diluting the capital stock. So if we were just to simply look at something like output per worker, if you increase L, right, the number of workers, that tends to reduce the GDP per capita. A bigger population will reduce the capital per worker. This applies to human capital as well as regular physical capital. Fast population growth means more children, which means greater strain on the educational system. Basically, findings that countries with fast population growth tend to have lower educational attainment. Now, there is quite a bit of truth to this assessment. Now let's think about different ways that you can mitigate this result. Okay, so the next slide is going to give us one extreme way, and then we'll look at a few that make some more logical sense. So to combat this potential future outcome of extensive population growth, countries have adopted different policies. China has adopted the one child per family law, which of course has had fairly significant impact in their outcomes. The unintended consequence of the 1980s one child policy is that you had male children far surpass the number of female children in the economy. Female infants were often killed in favor of then trying to have a male heir to support the family. Another way to combat population growth is contraception education and availability of contraception, which can work quite successful in many economies. And of course, the third, and probably the most prominent, where there's quite a bit of evidence, is to promote female literacy. If you notice, this was a calculation done by Barrow and Lee by the World Development Indicators in their study. And what they found is that years of female schooling and fertility had an inverse relationship. So as you had women spend more and more time in school, what happened is overall you got a decrease in the total fertility rate, so less children per woman. This is also a chart from Nigeria and Kenya. You can see here it graphs three different plots. The red line represents women with no education. The light blue is some primary education, and the darker blue completed primary or more. You'll notice in both of the countries, the women that completed primary or more tended to have a lot fewer children, right? And in any case, any amount of education even reduced the amount of children per woman. So we definitely don't like these type of authoritarian ways of doing this, but education and promoting female literacy is the way to reduce population growth to a manageable level. The third way is it could promote technical progress. So this is a positive component of population growth. Basically, more people means more scientists, innovators, and engineers, more frequent discoveries, and faster progress and economic growth. Evidence from Michael Kramer over the course of human history. Growth rates increased as the world's population increased. More populated regions grew faster than less populated ones. Now the natural resource curse. As we talked earlier about the natural resources being a positive, they can in fact also be negative. The resource curse, also known as the paradox of plenty and also Dutch disease, refers to the paradox that countries with an abundance of natural resources, such as fuels, fossil fuels, and certain minerals, tend to have less economic growth, less democracy, worse development outcomes, and countries with fewer natural resources. Dutch disease first became apparent after Dutch discovered a huge natural gas field in Groningen in 1959. The Netherlands sought to tap this resource in an attempt to export gas for profit. However, when the gas began to flow out of the country, its ability to compete against countries' exports declined. So with the Netherlands focused primarily on new gas imports, the Dutch currency began to appreciate, which harmed the country's ability to export other products. With the growing gas market and the shrinking export economy, the Netherlands began to experience a recession. The process has been witnessed in multiple countries around the world, included in Venezuela with oil, Angola, and the Democratic Republic of Congo with diamonds, and various other natures. All these countries are considered resource cursed. So Russia is another very good example of this as well. Natural resources and economic growth. Here you can see a chart here from the Changing Wealth of Nations from the World Bank. It says countries with the most prosperous populations tend to have high shares of human capital wealth and low shares from natural resources. So the way they created this index was they created a balance of the wealth, and they had human capital minus natural resources as a percentage of their wealth. You can see the wealthiest countries in the world. Here we have the median monthly income. The wealthiest, like the US and the UK, tend not to have many natural resources as the percentage of their output, whereas countries like Azerbaijan, Iraq, Mongolia, Guinea, Mauritania, and so on, some of the poorest, tend to have a lot more natural resources. Here in this chart, you can see countries and the percentage of natural resources that they have. And the dark orange is basically where your GDP is coming from between 75% to 100% based on extractive industries, which basically is oil and gas extraction. You can see a lot of Africa, the Middle East, obviously here, Iran, Saudi Arabia, Qatar, and so on. And the yellow are countries that are in the 50 to 74% range. Here you can see Russia, Mongolia, etc., and Norway. And then the blue tends to be the countries that are getting 0 to 24%. You can see Mexico here, South Africa, etc. So having a lot of natural resources doesn't necessarily generate economic. Conclusion. In the long run, living standards are determined by productivity. Policies that affect the determinants of productivity will therefore affect the next generation's living standards.